Centro de Investigación y de Desarrollo en Educación Bilingüe, CIDEP, WIT, Universidad Autónoma de Nuevo León, UANAL, in collaboration with Ms. Leilania Gomez, presents
Hello, ladies and gentlemen. We are going to talk about the importance of chemistry involved in the global warming and its effects in our daily life.
We will also give you information about the carbon cycle and its effects.
In the next segment, we are going with our correspondent, Judith Velez, who is going to talk about the carbon cycle.
We're going with Jerry.
Today I'm going to talk to you about the carbon cycle. The carbon cycle is a biogeochemical process through which carbon is exchanged among the biosphere, the hydrosphere, and the geosphere in the Earth. The first step of the carbon cycle is called photosynthesis, in which plants take in the carbon dioxide of the air and turns it into oxygen and nutrients for the plant. The carbon cycle is the consumption by animals, and this happens when the carbon present in plants reaches the animals through the food chain. Cold ocean intake, in which carbon dioxide is dissolved in the water of seas and oceans and is turned into sedimentary rocks. The fourth step is decomposition, in which the remains of living things decompose and change into fossil fuels. After that, the fossil fuels are used for industrial purposes, and this leads to the emission of carbon dioxide and other gases. At the end of the cycle, the carbon is returned to the atmosphere by the respiration process and the emission of gases.
As Judith just explained, every natural cycle has a chemical reaction involved.
Our partner, Ana Lucia, will explain the chemical reactions in the carbon cycle to you.
Well, as you know, chemical reactions are everywhere, and the carbon cycle is not the exception. I'm going to tell you about it in the next section.
The first reaction in the carbon cycle is photosynthesis, in which, as you know, carbon dioxide, water, and energy, that is the sun, produces glucose and oxygen. The second reaction is combustion or metabolism. Combustion occurs when organic matter is reacted or burned in the presence of oxygen to give off the products of carbon dioxide and water and energy. The third part of the carbon cycle is sedimentation, in which carbon dioxide is absorbed into bodies of water such as ocean and lakes. Some of the carbon dioxide remains in the water. The warmer the water, the less carbon dioxide remains in the water. Organisms such as coral and those with shells take up carbon dioxide from the water and convert it into calcium carbonate. The pieces of the shell fall to the bottom of oceans and accumulate as sediment. Humans impact the carbon cycle during the combustion of any type of fossil fuel, which may include oil, coal, or natural gas. These were formed very long ago from plant or animal remains that were buried, compressed, and transformed into oil, coal, or natural gas. Humans survive by burning the fossil fuels. During combustion in presence of air, carbon dioxide and water molecules are released into the atmosphere.
Thanks to human activity, big quantities of gases have been emitted into the atmosphere, changing the composition of this one. In the last 300 years, greenhouse gases have been increased. For example, the CO2 has increased from 0.035% to 0.046%. In the next section, Abigail Felix is going to talk us about the causes and effects of the increasing of CO2 in the atmosphere.
We're going
Hello,
with you,
my
Ana.
beloved friends. My name is Abigail Felix, and I'm going to talk to you about the causes and effects of increasing CO2 in the atmosphere. As we all know, global warming has been a problem that has affected the last years in our decade. There are multiple lines of empirical evidence that increasing carbon dioxide causes an enhanced greenhouse effect in our air. Laboratory tests shows that carbon dioxide absorbs long-wave radiation. Satellite thermometric measurements confirm less long-wave radiation is escaping to space at wavelengths that carbon dioxide absorbed at wavelengths. Surface measurements find more long-wave radiation returning back to Earth at the same wavelengths. The result of this is an energy imbalance of the accumulation of heat over the last 40 years.
In the next section, my partner, Adrian Rodriguez, will explain to you the chemical reactions involved in the global warming.
Global warming involves many chemical reactions. In the next section, I'm going to tell you about these chemical reactions and their process. There are many chemical reactions involved in global warming. First, we have the photosynthesis, which takes carbon dioxide from the atmosphere and converts it into oxygen. Then we have the greenhouse effect, which takes place when the planet takes in energy from the sun and remits some of the energy into space. Greenhouse gases in the atmosphere trap some of that energy before it leaves and then is directed back at the Earth's surface. Other chemical reactions that take place when the global warming is happening is the fossil fuels. The fossil fuels are compounds such as coal, oil, or gasoline. When these compounds are burned, nitrous oxides, carbon dioxide, sulfur dioxide, and mercury compound are released into the atmospheres. Those gases then increase the temperature of the Earth. Finally, we have the ozone, which is an important factor in the global warming too. Ozone generates heat by absorbing infrared and ultraviolet radiation from the sun and from the planet's surface, increasing levels of Earth's atmosphere.
Preview.
5, 4, 3, 2, 1, 0.